University student teams around Europe have been busy in the last months as they have made the final preparations for ESEO, the European Student Earth Orbiter. ESEO is part of the ESA Academy's hands-on programs preparing the space workforce of tomorrow. The student teams have designed, constructed, and tested essential parts for the mission, including subsystems, instruments, and ground control stations.
I'm very happy to see that ESEO is approaching its launch. During its whole project life cycle, ESEO engaged several hundred students, and already before launch we can say that it achieved all its main educational objectives.
After its launch, ESEO will be released into a polar orbit. When it wakes up, the first part to act is the power distribution unit made at Budapest University of Technology and Economics in Hungary. Then, ESEO needs to stabilize and reach the correct pointing for its mission to start. ESEO communicates with its main ground station in Forlì, Italy, where the ESEO Mission Control Center by the University of Bologna is located. The backup ground station is in Spain. It is managed by the University of Vigo. Aboard the satellite, there is a radio amateur communication system by the University of Surrey and AMSAT UK in the United Kingdom. This enables ESEO to transmit real-time data to schools and universities for science and engineering lessons. A GPS receiver and orbit determination system by the University of Bologna can determine the satellite position with high accuracy. And the attitude determination experiment from the Delft University of Technology in the Netherlands tests a novel software to estimate the orientation of the satellite. The data from all student experiments are received in Germany at the S-Bahn ground station by the Munich University of Technology. The communication subsystem for this high data rate transmission aboard the satellite is made by the Wrocław University of Technology in Poland. ESEO also carries several scientific experiments. Space radiation in low Earth orbit is studied by the Tritel radiation dosimeter from the Hungarian Academy of Sciences. The ionospheric plasma environment is studied by the Langmuir probe made at Budapest University of Technology and Economics in Hungary. The Estonian microcameras will take images of the Earth. These are conceived and built at the University of Tartu.
I participated in the LMP project. It is a bit a personal project for me because there is a component which I have in the design, and I wrote my thesis from this component.
I've been involved in the development and testing phases of the power distribution unit of the ESEO satellite. It's an amazing feeling that your device will go up into space and it's ready, it's working well, and I'm so happy.
ESEO is a complex system, and in the end I think it was challenging activity for all the payload teams. We had the chance to stay with them. We had the chance to teach them a few things that typically are not so common in academia.
ESEO gave us the competence to actually build any scientific instruments here in the observatory. It gave us both the competence and also the connections with ESA, and we learned a lot from the projects in order to develop our further missions.
Now the focus is on the ESEO mission to start. It will be launched on the 19th of November to low Earth orbit. The students will then be busy with the operations of the satellite at least until the end of 2019, when the last experiment aboard will be activated. The deorbiting experiment by the Cranfield University in the UK will deploy a lightweight, large sail to accelerate ESEO's re-entry and burn-up in the atmosphere at the end of the mission.